What if we released one of the most vicious and resilient predators on the planet against Australia's invasive animals? What if the honey badger, this small, indestructible creature, could become a living weapon against rabbits, cats, and toads? It sounds bold, even logical. But exactly such ideas most often end in a new catastrophe. Today, we will deconstruct one of the most dangerous ecological experiments being proposed as a real action plan in Australia. Subscribe. It will be interesting. Australia is perhaps the most vulnerable continent on the planet from an ecological perspective. For millions of years, it evolved in complete isolation. Its animals did not know large terrestrial predators in the sense that Africa or Eurasia know them. Kangaroos, wombats, koalas, and bandicoots, all of them formed in conditions where the main threat came from eagles, monitor lizards, and marsupial predators, not from wolves, cats, or rats. It was precisely this isolation that made Australian nature incredibly rich and diverse, but it also made it incredibly fragile. When Europeans came to the continent, they brought with them animals the local nature had never seen before. Some were introduced intentionally, others accidentally, and a third group escaped from farms and gardens. And all of this triggered a process that has not been stopped for over 200 years. The first and most famous offenders were rabbits. In 1859, only 24 rabbits were released in the state of Victoria for the sake of hunting. 10 years later, they numbered in the millions. 30 years later, hundreds of millions. Rabbits ate grass, destroyed plant roots, and turned green pastures into dusty wastelands. No other species in history spread so quickly over such a large area. Following the rabbits came the foxes. They were also introduced for hunting in the 19th century. Foxes quickly discovered that Australian wildlife had absolutely no idea how to escape them. Local animals simply did not know how to behave with such a hunter. In a short amount of time, the fox destroyed a huge number of small marsupials, birds, and reptiles. To this day, the fox remains one of the main factors in the extinction of local species. Feral cats became a tragedy of their own. Introduced along with the first settlers, they spread across the entire continent and turned into some of the most effective hunters in Australian history. Today, between 2 and 6 million feral cats live on the continent. Each of them kills up to 1,000 animals a year. They hunt at night, know how to camouflage themselves, and reach even the most remote corners of the country. Cane toads appeared in Australia in 1935. They were brought in specifically to fight beetles on sugarcane. The toads didn't handle the task, but they multiplied in huge quantities. They are poisonous to most Australian predators that tried to eat them. Crocodiles, monitor lizards, snakes, and cats died after tasting a cane toad. Today, there are more than 2 billion individuals. Rats and mice, arriving with the first ships, occupied their niche in cities, farms, and forests. They eat bird eggs, attack the young of small marsupials, and destroy crops and grain stores. Periodically, their numbers grow sharply and so-called mouse plagues occur. In 2021, such a plague caused damage to Australian agriculture in the hundreds of millions of dollars. A separate threat is posed by invasive plants, which displace native vegetation and deprive local animals of their usual habitat. No, but even among animals, the list does not end with rabbits and cats. Feral camels, pigs, goats, buffaloes, deer, and horses have taken root here, as well as several species of snakes and fish. All of this creates pressure on the local ecosystem from many sides at once. Australian authorities are not sitting idly by. Billions of dollars are spent annually on the fight against invasive species. Traps, shooting from helicopters, poisons, sterilizing baits, and fences hundreds of kilometers long are used. One such fence, the Great Rabbit-Proof Fence, stretches for almost 4,000 kilometers across Western Australia. But even it could not completely stop the spread of rabbits. Poisons also do not provide a complete result. The most common among them kill not only rabbits and foxes, but also local predators, birds, and marsupials. This is collateral damage that is difficult to control. Furthermore, some animals learn to avoid poisoned baits, and over time, the effectiveness of poisons decreases. Biological control, the use of natural enemies or diseases against unwanted species, seems like a smarter approach. This was the path taken in the middle of the 20th century when the myxomatosis virus was used against rabbits. At first, it destroyed up to 90% of the rabbit population. But rabbits developed a partial immunity, and their numbers began to grow again. Later, another virus was applied, but it also did not provide a final solution. It is against this backdrop that hypothetical ideas about new predators appear. The reasoning goes like this. Since Australia suffers from many small and medium-sized invasive animals, perhaps it needs a predator that will actively hunt them. And for the first time, authorities seriously considered bringing the honey badger to the continent. And at first glance, this does not seem like madness. The honey badger lives in Africa, the Middle East, and South Asia. It is an animal from the weasel family, about the size of a small dog, weighing from 7 to 16 kilograms. But in its fighting qualities, the honey badger has no equal among animals of such size. The Guinness World Records long called it the most fearless animal on Earth. The honey badger almost does not feel pain. Its skin is so thick and tough that most predators can barely bite through it. At the same time, the skin is very loose, which allows the honey badger to turn around inside a grip and bite the attacker back. Bee stings, porcupine quills, and bites from poisonous snakes, the honey badger endures all of this, gets up, and continues its business. The honey badger has developed a special resistance to snake venom. It regularly hunts African vipers, cobras, and other poisonous reptiles. A bite that would kill a dog or a small predator usually ends in a brief faint for the honey badger, after which it regains consciousness and continues the hunt. This property seems especially attractive in the context of Australia, where poisonous snakes are abundant. The honey badger is omnivorous in the broadest sense of the word. It eats rodents, birds, reptiles, insects, roots, fruits, honey, larvae, and carrion. It knows how to dig burrows at enormous speed, climb trees, and open locked boxes. Its intelligence is considered high for an animal of its size. In captivity, honey badgers have repeatedly demonstrated the ability to solve problems and use primitive tools. Australia is full of animals that the honey badger could theoretically hunt. Rabbits are ideal prey for a honey badger in terms of size and behavior. Feral rats and mice are as well. Cane toads, resistant to most predators, are not resistant to the honey badger, which can learn to eat them by turning them on their backs and eating the unprotected belly, just as some clever crows and snakes do in Australia. The arguments in favor of the honey badger usually end here. But this is exactly where the most interesting and disturbing part begins. Because history already knows examples of what such ideas lead to, and almost all of these examples end badly. It is enough to remember that the cane toad was also imported with good intentions. The first and main question that arises when analyzing this idea is as follows. Will the honey badger hunt exactly the animals we need? The answer is almost certainly no. A honey badger hunts what is easier to catch, what is tastier, and what is more accessible. It does not know that a rabbit in Australia is an invasive species, whereas a bandicoot, a small local marsupial, is a protected animal on the brink of extinction. Bandicoots, bilbies, quolls, small wallabies, and night parrots. Many of them live in burrows or on the ground, are active at night, and are about the same size as rabbits. To a honey badger, they are indistinguishable from desirable prey. Furthermore, local animals have no experience defending against such a predator. They have never met a honey badger and have not developed instincts that would help them escape. Invasive species, by contrast, are often much better adapted to surviving under predator pressure. Rabbits, rats, foxes, and feral cats have all gone through thousands of years of coexistence with various predators in Eurasia and Africa. They know how to run, hide, multiply at a huge rate, and restore their population after losses. Local Australian animals do not possess these skills to the same extent. This means that the honey badger is highly likely to cause disproportionately large damage precisely to the local fauna, rather than to the species against which it is supposedly directed. The honey badger will hunt what is easiest and most accessible. And what is easy and accessible in Australia are exactly those species that are already under pressure from other invasive predators. Now let us consider the question of reproduction. The honey badger does not have a high rate of reproduction. A female gives birth to 1, occasionally 2 cubs once a year or even less frequently. It would seem that this is a plus. The honey badger will not multiply as rapidly as a rabbit. But even with slow population growth, over several decades, honey badgers can occupy huge territories, especially in the absence of natural enemies. In Australia, the honey badger would have almost no natural enemies. Dingoes theoretically could pose a threat, but the honey badger is known to successfully fend off even packs of hyenas and lions in Africa. Large monitor lizards might try, but a honey badger is capable of standing up for itself against most reptiles. Wedge-tailed eagles, Australia's largest birds of prey, may occasionally attack young individuals, but an adult honey badger is practically invulnerable from the air. An absence of natural enemies is exactly what turned the rabbit, fox, and cat into a disaster for Australia. The honey badger will find itself in the same situation. It will multiply, albeit slowly, expand its territory, adapt to local conditions, and gradually occupy new niches. In a few generations, it will no longer be a control instrument, but a new, full-fledged inhabitant that no one invited, and that will now have to be controlled itself. Climate and the Australian landscape should also be taken into account. The honey badger comes from the arid regions of Africa and South Asia. Australian deserts and semi-deserts, which occupy most of the continent, are quite suitable for its existence. Climatically, the honey badger is well adapted to heat, lack of water, and meager food. This makes it a particularly dangerous candidate for the role of a new invasive species, precisely in Australian conditions. Let us imagine a short-term scenario. The first years after the introduction of honey badgers might indeed look encouraging. The animals will begin to hunt rabbits, rats, and mice. In some areas, the number of rodents may decrease. Farmers in certain regions may notice a reduction in crop losses. This creates an illusion of success and fuels the idea that the experiment is working. But by the second or third year, the situation will begin to change. Honey badgers, having quickly mastered the territory, will begin to face competition with each other and with other predators. Stronger individuals will take the best hunting grounds. Weaker ones will be forced to look for new prey. And it is at this very moment that local species, which do not know how to escape the new predator, will begin to suffer. In the third year, or shortly thereafter, reports of honey badger attacks on domestic animals may begin, on chickens and geese on farms, and on small domestic dogs. The honey badger does not fear humans. In Africa, there are known cases where honey badgers broke into chicken coops, sheds, and even residential buildings in search of food. In Australia, where many farms are located far from cities, this will become a serious problem. The question of the honey badger interaction with poisonous Australian snakes deserves separate attention. On the one hand, the honey badger is resistant to their venom and can hunt them. This seems like a plus, as some invasive snakes, such as the brown snake, have become very numerous. But on the other hand, Australian snakes are part of the local ecosystem, and a sharp reduction in their numbers will disrupt food chains. Snakes in Australia regulate the numbers of small rodents, lizards, and frogs. If the honey badger begins to actively hunt snakes, this will lead to an increase in the number of those very rodents from which Australia is already suffering. Thus, the honey badger can simultaneously put pressure on rabbits on one side and indirectly contribute to the growth of the rat and mouse population on the other by killing their natural regulators. One must not forget the impact on birds. The honey badger destroys nests, reaches eggs and chicks, and can climb trees. Australia is known for its diversity of birds, many of which nest on the ground or in low bushes. Species such as the night parrot, ground parrot, and scrub fowl will be extremely vulnerable to the honey badger. This is another risk group that supporters of such ideas rarely think about. There is another aspect that is usually missed in such reasoning. The honey badger actively digs burrows, sometimes very deep and branched. It destroys the soil cover, disrupts plant root systems, and changes the structure of the soil. In the arid regions of Australia, where the soil is already subject to erosion due to rabbits and other burrowing animals, adding another active burrower may increase land degradation. Suppose that after 5 or 7 years, the government realizes the scale of the problem and decides to take the honey badger under control. But the honey badger is extremely difficult to catch. It is almost impossible to catch in a trap if it has already been in one and escaped. It can bypass poisons if they are poorly disguised. It is smart, cautious, and incredibly resilient. Shooting is possible, but in hard-to-reach areas, it is extremely difficult and expensive. The history of biological control knows many cases where an introduced species turned out to be worse than the problem it was intended to solve. Mongooses, brought to the Caribbean islands to fight rats, destroyed local birds, reptiles, and small mammals, while only partially managing the rats because rats are nocturnal and mongooses are diurnal. The cane toad in Australia, mentioned above, has become a classic of the genre. Another example is the red-bellied squirrel introduced to some parts of the world, or the European starling in North America, which multiplied to 300 million individuals after only 60 birds were released in New York in 1890. The scheme is the same: a small beginning, rapid adaptation, explosive growth, and impossibility of control. Ecologists and biologists call such a process invasive pressure. When a new species enters an environment without natural limiters, it begins to use all available resources without restraining factors. In Australia, the honey badger would receive ideal conditions: a warm climate, plenty of prey, and an absence of competitors and predators capable of stopping it. This is a recipe for ecological catastrophe. Supporters of the idea sometimes object, what if we introduce honey badgers in small numbers and in a strictly limited area under the control of scientists? Theoretically, it sounds reasonable, but in practice, honey badgers are mobile, know how to overcome barriers, dig under fences, and find exits where no one expects them. Maintaining a population of wild honey badgers in a closed zone is practically impossible without extremely expensive infrastructure. Furthermore, biologists point out that even partial success of the honey badger in destroying invasive species will not solve the problem. Rabbits, rats, and cats reproduce significantly faster than the honey badger can destroy them. One honey badger cannot physically compensate for the deficit of predatory pressure required for a real reduction of the rabbit population on the scale of an entire continent. The mathematics here is cruel. One female rabbit produces up to 50 offspring per year. One female honey badger gives birth to 1 or 2 cubs. For honey badgers to exert real pressure on the rabbit population, many thousands of them would be needed. But thousands of honey badgers in Australia are no longer a biocontrol instrument, but a full-fledged invasion of a new predator with unpredictable consequences for the entire ecosystem. There is also an ethical side to the issue. A honey badger released in Australia will suffer from unusual conditions, diseases it has not encountered, parasites and pathogens for which it has no immunity. At the same time, it will itself become a carrier of new diseases for the local fauna. The biological exchange of pathogens upon contact of isolated faunas is often no less destructive than direct predation. All of the above does not mean that there is no hope against invasive species in Australia. Scientists are working on more precise tools. Genetic technologies, in particular gene drive technology, theoretically allow for the introduction of genes into rabbit or mouse populations that reduce their fertility. This is a so-called gene drive. It is currently at the research stage, but represents a much more manageable approach than the introduction of a new predator. Programs for the restoration of local predator populations are also actively developing. Quolls, Tasmanian devils, and dingoes in certain zones are all natural regulators evolutionarily linked to the Australian ecosystem. Their restoration and the expansion of their habitat is a significantly safer path than the introduction of an alien predator. The Tasmanian devil, for example, has already begun to return to mainland Australia after an absence of nearly 3,000 years. In 2020, a group of individuals was released into a sanctuary in northern New South Wales. The first results are encouraging. A local predator, familiar to the ecosystem, fits into it much more gently than any imported species. There has also been success in working with individual territories. On several small islands off the coast of Australia, it was possible to completely destroy cat and rat populations, after which local species began to recover with amazing speed. This shows that with resources and isolated territory, traditional methods can work very effectively. But scaling them up to the entire continent is extremely difficult. Let us return to the honey badger and summarize the hypothesis. The idea of using it as a biological weapon against invasive species is born from a clear desire to find a simple solution to a very complex problem. It is human nature to look for one remedy for many ills. But ecosystems do not work according to such logic. They are complex, interconnected, and extremely sensitive to interventions. A honey badger in Australia would highly likely follow the same path as all previous imported species. First adaptation, then rapid spread, then unpredictable consequences, and in the final, a new budget item for the government and a new problem for ecologists. Instead of solving the problem of rabbits, cats, and toads, Australia risks getting another aggressive and practically invulnerable predator that will be impossible to control. History has taught us a very clear rule. When a human tries to fix one ecological mistake with the help of a new living organism, they almost always make the next mistake. The cane toad was introduced against beetles, the mongoose against rats. Each time, the logic seemed ironclad. Each time, the reality turned out to be much more complicated. Australia has already paid a huge price for such experiments and cannot afford to repeat them again. Do you think it is worth introducing the honey badger to Australia? Is there any chance of defeating invasive species, or is this battle already lost? Be sure to write your opinion in the comments.